Today we're going to go over how to wire up LEDs, a single LED. There's several different configurations that you can do, including just wiring one, parallel, series, combinations of all of those. But today we're going to start off with just the basics. So if you're on our website, you can go over here to our blog. And we're going to have a series of blog posts. You'll find the how to wire LEDs here, the 101 single LED example, and we're going to kind of go over some of the formulas that you can use to calculate these values that we get as well, so that you kind of know what's going on. I'm basically just going to walk you through this article, and we will update it with additional parts. This will be a multi-part series. You'll see those different parts up here at the top as we develop them. So some of the things that you want to ask yourself when you're wiring LEDs, if you're not familiar with how to wire them or the resistors, is one of the things that we like to start with is what is the maximum voltage that your power supply is going to have? How many LEDs do you want? And we say what color are LEDs. Most importantly, though, is basically what the forward voltage is of them. The current is also very important as well, but we'll kind of get to that down the road here. So we've kind of chosen an example that seems to be quite popular, and that is wiring an LED in a vehicle. Most oftentimes it's thought of that a vehicle is just a simple 12-volt DC system. However, it actually will fluctuate in voltage quite a bit. You might see 11 volts all the way up to 15 volts. Ideally, it would just be 12 volts all the time, but sometimes it goes a little bit lower, and it almost always goes higher when the vehicle is running and the alternator is charging the battery. So 3 volts may not seem like a lot, but that can definitely throw a wrench in your design and ruin your LEDs and all the hard work that you've put into it. So we like to base, in this scenario, we like to base our maximum voltage off of around 15 volts. We have done this, and it works with great success. So the LED we're going to use in this example is a 5mm round top LED. So we can go ahead, we've included a link here, and I'll show you the information that you're going to want to look for. So here we are on the page for the specific LED that we're going to use in this example. If you click down here on additional information, you can also find this information too in the data sheet, but it's easy enough to just go down here in the additional information tab where it has basically all of the pertinent information to use the LED. So your forward voltage on this is 1.9 to 2.1 volts. That means that the LED needs, let's just say, 2 volts in order to function properly. At approximately 2 volts, it's going to use 20 milliamps. So those are the most important numbers that we want to look at. So we'll go ahead and go back to the blog post here. Alright, so here we are. So when you have an LED that only requires 2 volts and you have a maximum voltage of 15 volts, if we just applied 15 volts to that LED, then it would instantly burn out. So this is where we can use a very simple electrical component called a resistor in order to absorb, for lack of better words, the remaining voltage. It's actually called a current limiting resistor, but if you can think about it, it helps adjust the voltage and the current so that the LED does not burn out. That could have been said better, but it is a current limiting resistor, and it will allow your LED to work, your 2-volt LED to work on different voltages. And really that's just kind of what you need to remember, especially at the base level of setting up LEDs. So For those of you that care, there's some formulas here that you can use to calculate the appropriate resistor for this application. And we have them listed here. The first one is V is equal to IR. Voltage is equal to current. Current is shown as I. And resistance. So we'll go ahead and start off with that one. So calculating the resistance value. We'll do some simple algebra here to isolate R. So R is equal to V divided by I, which is current. So if we plug in some of our numbers, now this is for the resistor. So we will put in 15 volts for our maximum supply voltage minus the voltage of the LED, which is 13 volts. So basically, we want 13 volts for the voltage aspect for the resistor. And in the formula, you will use everything in terms of amps. So when we were over here, we had 20 milliamps. Well, 20 milliamps is 0.02 amps. So there's 1,000 milliamps in 1 amp. So you can just move the decimal point three places over and you'll get amps. So if we go ahead and complete this formula by dividing these out, the R, or resistance, will end up equaling 650 ohms. This is known as the resistance value, and it's really important. You definitely don't want to choose something under this value. You can go over the value and it'll be okay. The worst thing that's going to happen is that your LED might be a little bit dimmer, but if you go over, it'll be just fine. So the next value of a resistor that is important is the power rating. And this refers to how much heat that the resistor can dissipate. And that's how the resistor handles that additional power because they're wired in series. So 20 milliamps will run through that resistor as well. So anyways, we'll go through the formula here and you can kind of see how it works. Power, P, is equal to IV. I is current. So P is equal to 0.02 amps times it by 13 volts because we are calculating this for the resistor. And 13 volts is what the voltage drop will be across the resistor. So since this is being calculated, we have to say that 0.02 amps So if we go ahead and solve this equation that we have here, we will get that power is equal to 0.26 watts. Now a quarter watt is 0.25, a half watt is 0.5. So this is slightly more than a quarter watt resistor. Theoretically, these are theoretical values that we have calculated this off of. So in the real world, it'll actually probably be a little bit less than that, especially since most of the time the vehicle might be running at about 13 volts. But to be safe, we'll go ahead and bump that up to 0.5 watts, a 0.5 watt resistor, so a half watt resistor. So we're going to go ahead and choose the correct resistor since the actual dissipation is close to a quarter watt. Then we want to go ahead and choose a half watt. I like to bump it up to the next one, to the next value up for the power rating. This is not going to make any difference. The power rating isn't going to affect the brightness of your LED or anything like that. So you don't have to worry about that. So we'll go ahead over to the half watt resistors, which you can find here, and the closest value to 650 ohms, because they don't make resistors in every single value that you could calculate. There are standard values of resistors. So the next value up from a 650 ohm resistor is a 680 ohm 1/2 watt resistor. But let's just say we didn't know that, and we know that we're looking for a 650 ohm resistor, and it's going to be a 1/2 watt. So we'll go ahead and go over to the 1/2 watt resistor page, and we'll find which resistor is going to work the best. So yeah, these are listed in numeric order from least to greatest. So it's very easy to find what you want. Okay, so we have a 620 here, and then the next one's a 680. So we don't want to go underneath the value for resistance, because then we won't be providing the protection that the LED needs. So the next one up is a 680, which is going to be great. You're not going to really notice any brightness difference or anything like that. So that is the resistor that we would go ahead and choose for this application. It's a 680 ohm 1/2 watt resistor. So we'll go back to the blog here. All right. So now that you've chosen your resistors, there's just a couple things to note. Resistors do not have polarity, meaning there's not a positive or a negative side to the resistor. You can put them on in either direction, doesn't really matter. It's also easy enough to just put the resistor on the positive side of the LED. It's typically the longer leg of the LED. If you're using a different type of LED that doesn't have the legs, then it's typically marked by a notch or something like that. There's also a schematic or a diagram that will show which side of the LED is positive or negative. I can show you an example of that over here in this image. So you can see here, here's the cathode, which is negative on this particular LED, and this side of the LED is actually flat. You can see right here. Over here it's not. It sticks out a little bit. There's a little bit of a shoulder. And this is also the longer leg, which is the anode. Also, just a quick note. We have resistor charts on most all of our LEDs. So for a quick reference, I mean, you can print these off and keep them somewhere for quick referencing. The one thing that you do want to note is, this will be for a 2-volt LED, which is basically your red, yellow, and orange LEDs. And then all the other colors are mostly a 3-volt LED. And you can kind of tweak the numbers a little bit, but this is a quick reference chart that'll basically get the job done for you in quick time frame. So here we are. Look, our max supply was 15 volts. Resistance rating 680 ohm, 1/2 watts. So that's how you do that. And this is a little diagram on how to wire it up. It looks a little fancier than it is, but you have your power supply, goes into the resistor, into the LED, the positive side of the LED, and then this is the short side of the LED, the short leg, or the negative side, and then that goes to your ground. And we will also show you how to wire an LED as well in a moment using this exact setup. And we will show you what happens if you don't use a resistor, and then we will go ahead and add the resistor and show you how it functions as well. It's always going to be best to just solder the resistor onto the LED. We've heard of people doing some strange things like trying to glue them and do things like that. The best way is to solder. So get yourself a 25 or a 30 watt soldering iron and a little bit of solder, and you'll be good to go. It's very simple, actually. So that's all we have for this page. Like I said, this will be a multi-part series. You'll see those other parts of the series up in this top section, as we go ahead and get them added in, and then we'll go ahead and create videos for those as well. So we'll go ahead on to wiring the LEDs here. So here we have an LED set up on 2 volts, the voltage that it should work on. We're going to go ahead and turn up the voltage a little bit to see how quickly that it burns out. And right there it burned out at about 4 volts, so just a couple volts over what it was designed for. So that LED will never be able to work again. This is also the LED that we used that we were talking about in the tutorial earlier. It is the frosted version. It just makes it a little bit easier to see for demonstration purposes. So go ahead and put a brand new one in there, and we'll get it set up with the resistor that we spoke about earlier in the video, the 680 ohm half watt resistor, which will allow it to work up to 15 volts. So we'll go ahead and get that soldered on, and then we will turn the power source on, and we will turn it up to about 15 volts. So please excuse the soldering, it's a little difficult while recording and trying not to get in the way. So as you can see, we just put a little bit of solder on the LED, and then put a little bit of solder on the resistor, and then just quickly soldered them together on the long leg. It's a little bit crude in the video, but it'll work for all intensive purposes. Alright, so you can see the LEDs powered on. It's at about 4 volts or so there maybe. So we'll go ahead and get that turned up all the way up to about 15 volts. So you can see that the LED is fully protected up to 15 volts with that resistor. So it was extremely easy. And the resistor was soldered onto the longer leg. And you can see the ground there, the black clamp is on the shorter leg.